My name's Charles Johnson, and I want to present my programming language that I've been developing for quite a few years on the side. I'm like working full time as a CTO trying to build a next unicorn. So I'm just keeping this. Basically, been keeping this going. I've presented my progress a few times throughout the years of the Rust Seoul meetup. I guess since the last time I've been kind of keeping it going by like a kind of quite huge refactor, which I can kind of go into later. But I just want to present it now for all the people that haven't seen it before. So I'm trying to create a programming language that defines itself. So everything, you can like define all the passing rules in the language itself. One of the key features that I've tried to work on first is a way to dynamically declare operator precedence. Every programming language that I looked into, it's all like the way you determine, like, for example, how do you define when to like add two numbers together and when to multiply them in an expression. That's all kind of hard coded in like in the interpreter or the compiler, and then they normally just kind of assign a level. In the compiler or the interpreter itself. So that's all. And in that way I can like define. I'm trying to define as much about the language as possible in like the user space. And then I hope that the language can kind of evolve, and you're not stuck with a lot of like legacy, a lot of like decisions that had to be made in like the first version of the language, and that kind of never, you either have to like go to a version 2 and it's not compatible with previous programs, or you have to kind of just live with it forever. So so I've got like a few tutorials to show examples of how this is all working. So quite a common example of when people are showing their programming language off is to show how a factorial function works, because that's a quite easy way to demonstrate recursion and how to create functions and so on. So I'll show you how this works. So initially there's not much. There's not much like predefined when you like initially open this interpreter session. But what is defined are what I call concrete concepts that have labels, and they're highlighted in blue. And all the new concepts, all the new labels that don't point to any known concept, they're highlighted in green. So let is kind of similar to Rust let. It's kind of assigning a value, not to a variable. It can be an arbitrary expression, and And yeah, the other concrete concept is the reduction concept. So this is, so we're defining reduction rules, how to reduce expressions to their normal form. So first off, we start off with like the base case for the factorial, which is the explanation mark. So 1 factorial is 1, and and then also, as well as dynamic operator precedence, I have also what you can define in user space is the associativity of operators, or in general any concept. So so the increment operator plus 1, which I'm just defining to the interpreter for the first time. I'm saying that it's left associative. Currently, the interpreter assumes that everything is right associative. But here, for the way I want to write things, I define that as left associative, and then you can see how that plays out.
So plus 1 is like a new concept here, but you could have called it something else, like say plus plus or something like that?
Yeah,
okay.
Absolutely. And then so this is, from my study of mathematics, I understand this is an induction. So you start off with the base case, and this is the inductive step. I'm saying I'm interested in this is a new feature of variables. So I'm kind of inspired by the markdown notation to make things italic, because if you write things mathematically in italics, that is like a mathematical variable, which is different from what we normally in conventional programming languages think of variables. Whereas we think of variables as kind of things that are assigned a value, and that they can change value throughout the program. But in this case, when I'm defining reduction rules, when I'm defining reduction rules, I'm just saying that this reduction, you can substitute X for any concept, and then this statement will be true.
So it's like completely generic, like a typed variable, like A in Haskell or something. It's just like completely generic. You can put anything here.
Does the language, like if you don't provide the base case and the inductive case, does the language give you an error and say, oh, you can't define operators without defining?
So that's something that you can program in. You can kind of program. The idea is that you can kind of program in a type system, but the base layer of the interpreter is very permissive, I guess.
Okay, so it doesn't expect the proof of the operator.
So if it doesn't know the base case,
I'm trying to get a sense of how the constraint works for this.
So basically, the idea is behind the language to be able to extend or modify the compiler, while using the language. So let's say I don't like the current implementation of a specific operator, and the language would then give me, in my user space program, the ability to override that default behavior of an operator of the language. This is understanding correct? So let's say use the factorial, for instance, let's say instead of adding 1, within computing the next step, I could redefine that operator to instead add 2. Is this kind of how it works?
Yeah, you could redefine, you could redefine factorial as in like, yeah. So x plus 2 times x. So,
Yeah, right, that's fine.
Yeah. So then you'd have like 2 factorial equaling 3. So that's
But
Yeah.
it is interesting.
yeah.
That you can do that on the language level,
Yeah.
like,
So
Yeah.
in this case, you could take something like division, which languages are kind of split on whether or not like dividing an int by an int produces an int or float. You could instead define that on a program by program basis, where you say like I need this to be int going to int as opposed to int going to float. Is
I mean,
that-
you're talking about the type level, and I guess, I mean, you can configure like a type. You can, the idea is that you can like program a type system on top of this foundation. So I'm trying to focus on the foundation, the building blocks.
Sure.
That you can, you can build your own language on top. I mean, the use case, like the near term use case, I'm looking towards is kind of building like custom linters, custom like code validation tools, and so on, because you can like basically build kind of like a partial part of a language. You don't have to know, you don't need to know like every single like how to reduce every single expression in JavaScript, for example, or Rust. I think I'm trying to make it like you just need to know like the lex, like how to lex, I guess, and then you can just have like the minimal amount of information about how to pass things, and then from that you can like reason about possibly like finding bugs in code, or like just enforcing style or enforcing some constraint.
I'm sorry, like, I'm sure you said this before, but like, what was your day job again? Like, mathematician or something, or?
I'm the CTO of Clear, so
Oh, okay.
we're building the skincare tracking app with like, we have our community. We just recently reached 50,000 users and stuff, but it's not.
You have a degree in physics?
Physics with vertical physics. So
That might be
physics, skincare, Rust, programming language.
This isn't your day job, right? It's like,
No.
This is where the skincare recommendations come from. It's actually a custom rules engine.
So anyway, so I'm just showing, so I'm just defining how to like break down more, the higher, like larger factorials and so on. But then, if you might have noticed that like the multiplication symbol, the asterisk was also green. So the interpreter doesn't know anything about multiplication yet. It just knows that it's a reference in this rule. Kind of like custom concepts, or abstract. I call them abstract concepts that you've defined previously. It highlights that as magenta.
Does the underlying engine know that these are partial programs?
What do you mean? What do you mean by part?
You didn't define the asterisk symbol, right? So like, cause I'm wondering if like, to me, when I kind of see this, I kind of start thinking about type tables or something like this, where you're like, you're not providing the type, so it's permissive, but I could see a type. I mean, the way I would type this would be like, well, asterisk is a question mark to type something out, or the output of the asterisk. That's something I don't know because I don't define it yet. So you kind of want to like, you can kind of apply types over time if you define more criteria.
Yeah, so I think this is like, I guess I'm veering away from kind of the normal way of like thinking about programming. Like you normally think about variables as like a container of data.
Yeah.
And then you think of types as like constraints on that, what that kind of data is and how to interpret it. But the way I think of when I'm designing this interpreter is like there's this like just network of, there's like a knowledge graph of all these concepts, and it just knows relationships between those concepts.
Right. I guess because like without your text that says you need to define that, how do I know I need to define that?
Well, if you try to evaluate.
Okay.
So if you try,
yeah.
so so if you try to do like just type in 2 factorial,
Yeah.
and then click enter, it'll give you. Well, yeah, you also haven't defined what 2 is, but if you define what 2 is, it'll just give you.
Can we see it?
Oh yeah, this will go on. Yeah, I want to answer those questions. So yeah, this will just give you 2 factorial, and then that will reduce it just to 2, I guess.
So
Yeah, 2 times 1.
It will give you
2.
it'll give you a partial answer. Without,
Yeah.
okay, that's exactly what.
Yeah.
Okay, gotcha. Okay, cool.
Yeah, it won't like blame you.
You
It won't
can't
like
fully
say,
evaluate. You can only evaluate what it knows.
yeah, it's not going to like give you the steps you need to do,
Right. No.
but you can kind of, I guess.
So you said you're reducing it to whatever the lowest normal form is that
Yeah.
it knows about.
Yeah.
Yeah,
Cool.
but it's like kind of dealing with unknown information or like lack of information, kind of incrementally. Kind of, you just give it.
So in your underlying implementation though in Rust,
Yeah.
it knows it as some sort of type. There is some type there underlying that you don't like for like exclamation or for.
Or it's just a symbol or what?
Yeah, you can think of it as a symbol.
Yeah.
Yeah, like this is like symbolic.
Yes, this is,
Symbolic.
I think this is symbolic execution.
Yeah. So we define what multiplication is in terms of this. Well, what timesing? Yeah, what
Or define
the
times
base
4.
case for
Yeah.
multiplication. And yeah, then we can define what 2 is. So actually, all these are reduction rules. But actually, you can also define what a concept is, kind of structurally. And in that case, I have this. This assignment operator that I've just. Well, yeah, it's all like the interpreter already knows about that. It's a concrete concept, so it's blue. But then 2 is a new concept you're introducing, so it's highlighted in green. And yeah, 1 plus 1 that you already knows about. So highlights that in magenta. So yeah. And then finally you can evaluate 2 factorial. This is like it must be like the longest example of.
But then it unifies under the hood. It unifies everything.
Yeah, like chains all
Yeah.
these. All these reduction rules and kind of searches. Searches all the graph of possible patterns and stuff. Match.
This is symbolic execution. Just totally that. Okay. Now I understand.
So the steps for that last step, 2 factorial is, it breaks down into 2 factorial. It's 2 times 1 factorial. Is that correct? Like the grammar applied to the last step is The third green line, is that the first one to
It
break
doesn't
down?
go to that straight away.
Okay,
This first needs to reduce 2 to 1 plus 1, or?
Yeah,
just make two?
and then
Ah.
because
One
it
and then
knows
plus
like,
one is a
it's
symbol.
structurally like this, it can find a match
oh.
to this. So then it knows like to apply this reduction rule. And so then you've got 1 plus 1 times 2. Oh no, 1 plus 1 times 1.
Okay.
But then it knows that this is just 2. Yeah, so there's 2 times 1, and then it knows that anything multiplied by 1 is itself, so
Okay.
it's 2. Yeah, on the left.
Gotcha.
Wait, so the only thing you start with is just 1? Like,
1 he defined himself as, or a 1, yeah, it's just
Oh.
a symbol, right?
Yeah, I didn't define what 1 is like structurally because I don't. Yeah, because I only need to get to this step.
Is one already defined by the language?
No.
No. It basically can unify and figure out what one is.
It's like church encoding, right?
You know, you don't have to know what 1 is because x times 1 reduces to x, no matter what x is.
Oh, got it.
Yeah, I mean, it doesn't.
Okay.
Yeah.
This whole, this
Okay.
interpreter isn't thinking
This-
of these numerical symbols as like, it's not kind of mapping it to like a U32 or something.
So if you ever use like the original quick check stuff, essentially you're building out, you use symbolic, you create your functions
Yeah.
for a generator, but you say these are symbolic things. And then it figures out using the, over constraints and it unifies and says, oh, this is the thing that we can generate. Very similar. I mean, reduction relations in the language bracket has a variation of this too.
Yeah.
So you could in theory take this entire sequence and say instead of 1, redefine it as like in terms of flurbid, right? So let flurbid factorial goes to flurbid, and then go the entire way down. It would still give you 2.
Yeah.
Is that correct?
Yeah.
Yeah, as long as you
You don't
match
know what
the
one is.
match the symbol 1 with this,
Gotcha.
I guess.
Third.
Yeah. Oh yeah, sorry, I missed a step. Yeah, like it needs to know that 1 factorial is actually 1,
Yeah.
and then it goes to this. It finds this rule and applies that.
Is plus 1 without spaces its own symbol, or?
Yes. So
Like it could have been just like plus plus or
Yeah,
whatever.
yeah, so-
Foo.
like the lecture for this is very simple. It's just separating. Well, it knows about parentheses and spaces. So spaces just separate out the symbols, and then parentheses are like they're just kind of nest expressions. But yeah, later I can show like how you can use like have this like dynamic operator precedence, so you don't need to write as many parentheses. Yeah, so you don't have like run into so the language doesn't become this basically. And actually it makes some assumptions. I said before, like it assumes that these operators are right associative, so you can kind of think of it as like a tree that's like really lopsided to the right. If you break down this expression, they're like syntax tree. It's always a binary tree. Yeah, it always reduces to internally as a binary tree. That's kind of hard to explain just with these examples. Okay, and then we can go to the define free, and then okay. So what do you think it's gonna return now? 3 factorial. So we've got this, so it knows that 3 is 2 plus 1. so I can check for any rules around that. So we can actually see, okay, yeah, this rule applies where x is 2.
I think it eventually runs out of, it's not going to reduce to a number as we think of it.
Yeah, it's not going to reduce to a single symbol. So reduce it to 3 plus 2. So we haven't like fully defined multiplication. We only know how to just multiply something by 1. Oh, that's interesting.
The syntax highlighting things.
Yeah, it's
Turn it into word art.
it's overlay. That's interesting. I'm like kind of doing a hack where I like overlay like an invisible copy of of this text input to get everything working in the web. Anyway. Yeah, so this is the precedence operator, it's a prec, so it like prec and then the concept that reduces to the precedence of the relative precedence of that operator. So yeah, multiplication has a higher precedence than multiplication. So yeah, 4 times 6 plus 1, like you do the multiplication first. And then after you've like processed all the multiplication, you can then you can process the addition.
might be getting kicked out. 시간 됐어?
9시
아, 네.
10분인데 지금.
아, 네.
하셔야 되는데 어느 정도 하시면 돼요? 얼마?
How long are?
I mean, I was going to show like the merge request itself. It's probably
We'll probably finish next time. Yeah.
Yeah, we-
그래도 막 떠본 다 마음이야.
Yeah. Maybe we can just wrap up with some,
Yeah.
questions. I think.
Yeah.
Yeah.
So it's very platonic, I like it. Higher order forms.
Yeah.
Yeah. Have you used it for something practical in your like?
So I mean, the process of developing this and everything I've learned a lot from. So like, yeah, finding an application of this is still.
What's the most challenging part for the underlying implementation?
It's just like I end up like rewriting, like refactoring everything to kind of add the new feature and stuff. But that's kind of the big part of the learning journey of it. And that's helped me refine my.
How many years?
Since 2018 or so.
So when I started my PhD.
Yes. Thanks.
Are you going to open sources or like release it?
Yeah, it is open source on GitHub. You can just search Charles Johnson with a hyphen.
You can share the link on the Telegram.
Yeah, sure. I think this is the